$2,500, this little tower here. $2,500. Okay, step number 1, are there any parentheses? No, so we're jumping to step number 2. We're looking at the lowest common denominator. The y is over 1 that we don't see, and the 2 is over a 1 that we don't see. So what's the LCD between 1, 2, and 1? 2. So all I'm going to do is multiply every single term by 2. So I'm going to multiply the y by 2, the x by 2, and the 2 by 2. 2 times y is just 2y. The 2 is going to cancel with the denominator. That's why we've multiplied by 2. So all that's left is negative 1x, which I'll just get rid of the 1 in a second. And then 2 times 2 is plus 4. After step 2, you shouldn't have fractions. If you have fractions, you've done something wrong, because that's the point of step 2, is to get rid of them. Step 3, everything's going to go over to the left-hand side. How do I get rid of negative 1x? Add 1x, so I'm going to come here and add x. How do I get rid of plus 4? Subtract 4. So I'm going to do both of those in one step. So I've got x plus 2y minus 4. And on the right-hand side, 0. And you should have a 0 after step 3. If you don't have a 0, you've done something wrong. The last step, we just take a look at x. Is it negative? Then we're done. That's standard form of this line. Standard form for this one is x plus 2y minus 4 equals 0. We're just going to graph them in a second. Yep. So if you look at the original question, which was our y equals negative a half x plus 2, and this guy here, these are the exact same line, just the equation looks different. The only reason we have 2 equations is because one is for graphing, one is to compare against different functions. That's the only difference between them. Letter B. Any parentheses? Nope, so step 1 is done. Any fractions? Nope, step 2 is done. What's step 3? Move them to the left-hand side, so the negative 2x has to go over and the 6 has to go over. What's the opposite of subtracting 2x? Adding 2x. What's the opposite of adding 6? Subtracting 6. And I'm just going to do those in one step. The order matters, so the x's come first, so I have 2x, then the y, then the constant, and on the right-hand side, 0. The last step, we just take a look at x. Is x negative? We're done. That's the line in standard form. Show me your thumb so far. Getting it, getting it, getting it. Good. Okay, let's do a nasty one with fractions. I know, I hate them too. Step number 1, are there parentheses? Okay, so we need to distribute that number through each of those numbers in the brackets. What's under the x that we don't see? And what's under the 3 that we don't see? So left-hand side, I'm not touching yet. Here we multiply top times top, bottom times bottom. So negative 5 times x, negative 5x. 2 times imaginary 1, 2. Negative 5 times positive 3 is negative 15. 2 times imaginary 1, 2. Step number 1 is to get rid of the brackets. Step number 2, we need the lowest common denominator. I have an imaginary 1, I have a 3, I have a 2, I have a 2. What's the lowest number that I can divide by 3 and 2 and 1? 6. So I'm going to multiply the y by 6, the negative 2/3 by 6, the negative 5 on 2 by 6, and the negative 15 on 2 on 6. 6 times y is the easy one, 6y. Here's what's going to happen and what you're going to do wrong, is people go 6 times negative 2 and 6 times 3. It's a 1 on the bottom. Okay? So the top is negative 2 times 6 is negative 12. And on the bottom, Good, isn't it? Well, it's just 3, because 3 times 1 is 3. And I'm going to reduce that fraction in a second. Okay, so what I just did was 6 times 2, or negative 2, and 1 times 3. Same thing here, we've got imaginary 1 on the bottom. So the top is 6 times negative 5x, which is negative 30x. 1 times 2 is 2. Still imaginary 1 on the bottom. 6 times 15. Okay, we'll do 15 times 2 is 30. Add another 15. Add another 15. Add another 15. And then add your last 15. Is what I heard. 90, agree? And again, the mistake you're going to make is you're going to want to do 6 times 2. No, on the bottom there's 1 times 2, which is 2. Now I said if you still have fractions, you've done something wrong. Why do we still have fractions? We're just not done yet. We haven't reduced them. So what is negative 12 divided by 3? What's negative 30 divided by 2? Negative 15. And what's negative 90 divided by 2? Negative 45. I'm going to show you a shortcut. I'm just going to take the last fraction rather than showing you all. So what we had was 6 times negative 15 on 2. What we did was the multiplication, and then we reduced. If you want a shortcut, what you can actually do first is the division. So that's going to give you one step. If we do the division first, what's 6 divided by 2? 3. And then what's 3 times negative 15? Minus 45. Gives you the same number, just does it in one step instead of 2. Completely up to you. You can multiply, then reduce, or you can divide first, and then you won't have to reduce. I did the top divided by bottom. Okay, step number 3. Step number 3. Okay, what's the opposite of negative 15x? What's the opposite of negative 45? The x's come first, then the y's. Then we simplify, plus 45, negative 4 equals 0. Check your x. Is it negative? Good to go. Find someone who looks smart. Do D together. I'll give you a couple minutes, then we'll talk. I'm going to slowly start working through it. Sorry? Oh, thank you. Questions so far? I'm eavesdropping on them over there. I'm just eavesdropping. Where'd I get the minus? 1 times negative 12.
Oh, you already simplified it?
No, well, okay, so 1 times negative 12. 6 times imaginary 1. What's negative 12 divided by 6? What? Oh, what? Oh, what?
Skip
What?
some of that.
Oh, I so did. We're okay there where it came from? Other questions so far? How do I get rid of x? How do I move it to the other side? The xy, put it away. How do I get rid of minus 12? Uh-oh. 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 What do we do in this step when the x is negative? Multiply by negative, so you're going to have x minus 6y minus 24 equals 0. The reason we don't love standard form is because can you look at it and know what the slope is? Can you look at it and know what the y-intercept is? We like standard form when we're comparing against other kinds of equations. But for graphing, standard form sucks. Second thing we're going to do today is take standard form and graph it. This is fun because we've already done it all. How do I know by looking at this, this is the equation of a line? No exponent greater than 1. How do I know by looking at it, this is a standard form of the equation of a line? It all equals 0 and x is positive and no fractions. So I know just by looking this is a line because there's no exponent greater than 1. I know it's standard form because the right-hand side is 0. The x is positive and there's no fractions. I want to graph it. How do we graph it? Yep, we change it to slope-intercept form. What is slope-intercept form? Y equals mx plus b. So we want to get the y by itself, just like every other equation we've graphed so far in this unit. How do I get rid of 2x? Minus 2x. How do I get rid of plus 12? How do I get rid of a coefficient of negative 3? You have done this probably 40 times already. What can I do with negative 2 over negative 3? Perfect. What can I do with negative 12 over negative 3? Plus 4. I actually gave you a question almost exactly like this when you walked in. You just didn't know it was in standard form. Ta-da! How do we graph it? Go 4 units. Up. 2 up, 3 over. How do you know it's 2 up and 3 over and not 2 over and 3 up? Rise over run. And what do you put at the end when you draw your line? Arrows. No different than what we've done in the first part of this unit. The equations are just in standard form. That's it. I want you just to pause for a second and think back to Unit 5. We did linear equations in Unit 5. We did all those questions like driving until the gas runs out and people going to renting things or having a dinner party at a restaurant. Exactly the same mathematics, just completely different approaches. If you liked Unit 5, applied would be best. If you're liking Unit 6, pre-cal would be best. But that's why I wanted to show you the same material shown in 2 completely different ways. Okay, how do I get the y by itself? minus 4x and? So let's start doing this in one step, just like we did the last one. So we know it's going to be minus 4x. And what's going to happen to the minus 2? Plus 2. Andrew, it's not nap time. Where do we start? With the 2, and where do I put it? Okay, right here? Ooh. Why on the y-axis? Because it's the y-intercept. I don't have a fraction for slope. I've only got -4. Oh, there's a what now? Look at that. So I'm going to count 4 units down and 1 over. Is this any harder than what you've done in the previous part of the unit? No, the equations just happen to be in standard form. This one we're going to be a little sneaky. Instead of moving the x and the number like we usually do, I'm going to move that -6y. Why am I going to move the y this time? Because I want the y to be on the left. So what's the opposite of subtracting 6y? Again, phone's away. I don't have my phone out. You shouldn't have your phone out. Unless you have 100 in this course, you may not have your phone out while I'm teaching. What's the opposite of subtracting 6x? Adding 6, or I meant y, adding 6y. What do I need to divide by? Can I reduce 3 on 6? I know what you meant. Can I reduce 18 on 6? Graph it.